Hydrogen. Hydrogen. 1. Properties of hydrogen. Symbol is H. Atomic number is 1. Atomic weight is 1.008 g over mole. State. At room temperature, hydrogen is a colorless, odorless, and tasteless gas. Density. Hydrogen is the lightest element in the periodic table, making it much less dense than air. Boiling point, minus 252.87 degrees Celsius, or minus 423.17 degrees Fahrenheit. Melting point, minus 259.16 degrees Celsius, or minus 434.49 degrees Fahrenheit. Reactivity, hydrogen is highly reactive and readily forms compounds with most elements, especially oxygen, forming water, H2O. Isotopes. Hydrogen has three isotopes, protium, H, deuterium, D, or heavy hydrogen, and tritium, T, radioactive. 2. History of hydrogen. Discovery. Hydrogen was first recognized as a distinct substance in the late 1600s. The name hydrogen came from the Greek word hydros, water, and genes, forming, reflecting its role in forming water. First isolation. In 1766, British scientist Henry Cavendish discovered hydrogen as a separate gas and recognized its flammability, calling it inflammable air. Role in water. In 1781, Antoine Lavoisier identified hydrogen as a component of water, laying the foundation of modern chemistry. 3. Chemistry of hydrogen. Molecular form. Hydrogen exists as diatomic molecules, H2, in its natural state. Reactions. Hydrogen readily combines with oxygen to form water. It also reacts with many elements, especially metals, to form hydrides, for example, sodium hydride, NaH. Acidity. Hydrogen gas, H2, is neutral, but hydrogen ions, H+, are acidic in aqueous solutions, forming hydronium ions, H2O+, in water. 4. Occurrence of hydrogen. Earth's atmosphere. Hydrogen is relatively scarce in the Earth's atmosphere due to its low molecular weight, which causes it to escape into space. However, it is found in compounds like water, H2O, and hydrocarbons. Cosmic abundance. Hydrogen is the most abundant element in the universe, making up about 75% of its normal matter by mass, primarily in stars, including the Sun. 5. Production of hydrogen. Hydrogen can be produced by several methods. Steam methane reforming, SMR, the most common method where methane, CH4, reacts with steam, H2O, at high temperatures to produce hydrogen and carbon monoxide, CO, CH4 plus H2O to CO plus 3H2. Electrolysis of water. Electricity is used to split water molecules into hydrogen and oxygen. This is a cleaner method if renewable energy is used for the electricity. 2H2O to 2H2 plus O2. Partial oxidation. Hydrocarbons, such as natural gas or oil, are partially oxidized to produce hydrogen and carbon dioxide. Coal gasification. Coal is gasified with oxygen and steam to produce syngas, which can be further processed to obtain hydrogen. 6. Storage of hydrogen. Storing hydrogen is challenging because of its low energy density and volatility. Methods include compressed gas. Hydrogen is compressed into high pressure cylinders, typically at 350 to 700 bar. This is the most common form of portable storage. Liquefied hydrogen. Hydrogen is often cooled to cryogenic temperatures, minus 253 degrees Celsius, to turn it into a liquid for denser storage. Metal hydrides. Some metals can absorb hydrogen and form hydrides. These materials can store hydrogen at lower pressures and higher densities, but often require heating to release the hydrogen. Chemical storage. Hydrogen can be chemically bound in compounds like ammonia, NH3, or liquid organic hydrogen carriers, LOHCs, and released when needed. 7. Applications of hydrogen. Energy. Hydrogen can be used as a clean fuel in fuel cells where it reacts with oxygen to produce electricity, water, and heat. This is used in electric vehicles, hydrogen-powered cars, and stationary power generation. Industry. Hydrogen is used in refining petroleum, producing ammonia for fertilizers, and in hydrogenation processes for making edible oils and other chemicals. Space exploration. Hydrogen is used as rocket fuel in its liquid form, liquid hydrogen combined with liquid oxygen, LOX. Electronics and metal industries. Hydrogen is used in the semiconductor industry and as a reducing agent in metal production, for example, reducing ores. 8. Safety and precautions. Hydrogen is highly flammable and poses several safety risks. Flammability. Hydrogen can form explosive mixtures with air, 4% to 75% of hydrogen in air. It has a very low ignition energy, making it easy to ignite by sparks or even static electricity. Storage. Due to its small molecular size, hydrogen can leak through many materials, making storage and transportation challenging. Proper seals and safety protocols are necessary to prevent leaks. Explosion risk. If hydrogen accumulates in confined spaces and ignites, it can cause powerful explosions. This is a concern in industrial settings, particularly in the production and storage of hydrogen. Handling. Proper ventilation is necessary when working with hydrogen to avoid the buildup of flammable concentrations. Hydrogen detectors are also essential in areas where hydrogen is used or stored. Hydrogen embrittlement. Hydrogen can cause metals to become brittle over time, particularly in high pressure environments. Special materials are often required for the construction of hydrogen storage tanks and pipelines. In summary, hydrogen is a versatile element with significant potential for use in clean energy, industrial applications, and transportation. However, it requires careful handling due to its flammability and the challenges associated with its production and storage.